Hey guys, hope you're having a good day. Today we're going to be looking at this integral right here of 1 over x squared plus 4 from minus infinity to plus infinity. So the first thing we got to do is replace the infinities with constants. So we get our new integral from a to b dx x squared plus 4. And as you may have noticed, this x squared plus 4 is quite similar to 1 over x squared plus 1. And if you recall, the integral of 1 over x squared plus 1 dx is equal to arctan x plus c. And so if we get this somehow into the form of x squared plus 1, we can use this formula here to get an arctan something, 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 So that's what we're going to be using. So the first step is going to be to take a factor of 4 out of here in order to achieve this 1. So let's do that. So we get a 1/4 in front of the integral a b 1 over, and now x squared divided by 4 because we took a 4 out, plus 1 dx. All right. So now we see that we got the 1 here, and now we just need something squared. So what can we replace here to make this just a squared term? We can replace x over 2 with u in order to get u squared, right? So u equals x over 2. So u squared is x squared over 2 squared, or x squared over 4. And now that we can replace this with a u squared, we differentiate u in terms of x, and we get a half. And now to get du, we do, and now to get dx, sorry, we do 2 du equals dx. So now we have dx in terms of u, and we have this term in terms of u as well. So let's get our new integral. Delete, delete, delete. So now we have a quarter a b dx over x squared over 4. 1 equals 1 over 4 a b 2 du over u squared 1. And now, as we can see, we can take the 2, which is a constant, to the front of the integral to get a half here. And now we just have a 1 over something squared plus 1. So the integral of this is just arctan. So we get 2 to the front with the quarter, gives you a half. So we get a half arctan u to the boundaries of a and b. And the next step would be to compute this here. So let's do that next. So we had that u equals x over 2, and we got the result of a half arctan u to the boundaries of a and b. So we get a half arctan. Replacing the u with the x over 2, we get half arctan x over 2 a and b. And of course, the boundaries here are in terms of x. This is a bit of a abusive notation right here, but so you can't actually write this. Sorry about that. You would have to put these boundaries in terms of u, but we go back to x anyway. So these are in terms of x, okay. And now we take the limits of a and b to plus infinity and minus infinity respectively. We'll take the limit a approaches infinity and b approaches minus infinity of half arctan, and we'll just do the expansion here. So arctan a over 2 minus a half arctan b over 2. And from the graph of arctan, which I'll do up here. As you can see, the graph of arctan is as such. Goes through the origin like so, and also on the other side. And as we see, it flattens out here. Boom, 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 boom. And the value at which it flattens out is pi over 2. And on the negative side, it's minus pi over 2. All right, so as arctan, a over 2, as a approaches infinity, a over 2 also approaches infinity. So arctan of infinity, as we can see here on the graph, as x approaches plus infinity, we also get that y approaches plus pi over 2. So this becomes a half times pi over 2. And now let's look at the negative side. b over 2, arctan minus infinity over 2 is arctan minus infinity. As arctan approaches minus infinity, it approaches minus pi over 2. So now here we get a half pi over 2 minus a half minus pi over 2. So this is a pi over 4, and this is plus a pi over 4. So 2 times pi over 4 equals pi over 2. And that's the answer. So our original integral converges with a value of pi over 2. Hope you learned something. See you on the next one. Sorry about the bad notation here, but I can't be bored to record the video again. So see you guys next time.